Hi all. In this video, we are going to present a paper titled End-to-End Object Detection with Transformers. So we have seen so far that deep learning based object detections has two types. One is two stage like RCNN and fast RCNN, and single stage like faster RCNN or SSD or YOLO. Uh, all these architectures are based on a traditional convolutional neural network architecture. But this paper makes an attempt of using a now the state of the art language model architecture called transformer architecture in order to predict objects in the image. How it does it takes inspiration from two papers. So this is something that I wanted to note that here in this paper they say that they take an inspirations from a paper called faster RCNN, which is from the same group like facebook Facebook AI. But I would say that this paper is based on two papers. Mainly, this paper is based on this paper, which is multi-box, deep multi-box architecture, which was published way ahead than FASTA CNN and other FASTA CNN like in 2013. And this is from Google. So what it does, this paper does is it is clearly explained in section 3. We also put up poster presentations possibly today. So this paper gives a deep neural network architecture based object detections. It uses a single deep neural network architecture like a standard like convolutional neural network, which takes an image pixel image of 220 cross 220 into as an input and tries to predict k bounding boxes. K can be an order of 100 to 200. So it straight away predicts K 100 to 200 bounding boxes and try to match with the ground truth bounding box in each image. The ground truth bounding box in each image, as we know, it's not going to be 100 or 200. It's going to be in order of like around 5 to 10. So the generated bounding boxes or predicted bounding boxes is way order of magnitude higher than the ground truth bounding box. But they are going to formulate an optimization problem like similar to an assignment problem, like using an Hungarian algorithm or some similar to that kind of setup, where they have two objective functions. One is match objective functions, which is going to minimize the error, regressor error between the bounding box coordinates and the ground truth bounding box coordinate. And where this is going to be assignment problem, as mentioned earlier, is going to be take 1 or 0. If it is 1, it's going to be a match the corresponding object category. If it is 0, it's not having that corresponding box, doesn't have any object and that doesn't belong to any category. And the classification error is based on this loss functions, where if it is an object is detected, it's going to identify whether it belongs to a particular category or not. So combined, this one is going to be optimized in this equation 3, where alpha is a trade-off between this matching error and the confidential score error for each bounding box. And this is going to be formulated as an assignment problem where it's going to take 0 to 1 value. The similar setup is being done in this problem. It's not this paper says that they are trying to follow the what similar to a fast RCN. No, they are trying to follow the what similar to multi-box, and they formulated this setup like assignment problem is something like a bipartite matching problem only. So this is one thing. So they take inspiration from the multi-box thing. The second thing is they try to formulate this object detection as a sequence to sequence prediction similar to language problems. For this, we can take this paper as an example, where we wanted to have a machine translation like neural machine translation architecture, where there is an encoder decoder based mechanism, where encoder encodes the input language, like for example German language, and those encode for example if you are taking an English sentence, that whole thing is encoded using an RNN architecture like LSTM into a single context vector. That single context vector have all this spatial related information of this particular input sentence like German, and that has to be predicted into English sentence like Y1 to YT, and that would be done by a decoder where it utilizes all these informations embedded in this context vector, giving to all which is unrolled in time. So this same kind of encoder decoder architecture, like sequence to sequence prediction, is was done by transformer neural network architecture, which we will put it in the separate video series, how to demystify to understand the transformer neural architectures, which put up purely attention based mechanism instead of completely bypassing the RNN due to the cumbersome back propagation through time. So that is what it done in this paper. So they are trying to put a sequence to sequence predictions for object detections instead of using a standard neural machine translation like using RNN based encoder decoder mechanism. They are using a transformer neural network architecture based sequence to sequence predictions, where they try to predict like a sequence. Here they try to predict in a machine translation, they try to predict a sequence of words, putting an input of sequence of words from the another language. Here, in a similar fashion, they try to predict n objects as a like a kind of a sequence predictions, which we will be detailing first to understand about the transformers, how the transformer works, how the attention mechanism works, what is queries, and how that queries and the queries are how the queries are work, how the input queries is done to in order to predict the to predict the output sequence to be like a query matching. So those kind of transformer based things are being embedded in this paper called uh, I'm sorry, not this paper. This is oh, not this paper. I'm sorry about that. Yeah, this is the paper which introduced transformer neural architecture, and how it says that how it differs from the like kind of a standard neural machine translation, putting this architecture into account, putting encoder decoder mechanism, not utilizing any recurrence mechanism in either in encoder or a recurrence mechanism in the decoder. So this is what we are going to do it here. So again, I'm coming back to like a bird's overview of this data. We will be putting more additional videos to understand how this sequence to sequence predictions for object detection is set here, and what does mean by query, what does mean by value key value pairs, and how that key value pairs are taken into queries, and through these things how the attention mechanism, multi-head attention mechanism works, and from that attention mechanism how they make a connection between encoder and decoder and try to predict regression and the classifications based type of object detection using the data, and what are the limitations of data while classifying the small objects, and how it takes the global picture. All these things will be coming into the later part of the this data explanations in the separate videos. But here I want to give you a bird eye view, but it based on two things. One is like I mentioned earlier, it is based, this paper is purely based on multi-box based architecture, like I explained in this paper, uh, which uh, which formulates as an assignment problem utilizing this it for it taking an input image of certain pixel size and tries to predict k bounding boxes, and that k bounding box is usually very large number compared to the ground truth bounding box for each image, which will be like 5 to 10, and they try to make an assignment problem to try to find the best bounding box among this 200 matching with the ground truth bounding box. For that, they make another objective function like confidential score, which has a highest top 10 confidential score will be taken into account for the further classification problem. So it's like a two-stage. First, it tries to regress and try to pick up the top performance bounding boxes. Then that bounding boxes would be further put it into a classification stage to identify which objects belongs to. A similar strategy is what's taken here. Instead of using a single network architecture, they try to put like into a sequence to sequence predictions, and sequence to sequence prediction like putting this predicting this n objects in terms of predicting n words in a sequence. So that's what it's all about. So if it is an if it's going to predict a sentence, something like kind of an English. So each word will be like a particular object in an image. The whole image will be act like a sentence, and this image whole will be made out of different objects, and each object will be act like a word predictions from this transformer encoder. So this is what the whole picture. And convolutional neural network is preliminarily they are put it into have some kind of a image feature extraction that will be given into the encoder and decoder mechanism, and that encoder decoder mechanism going to predict sequence, and each element in the sequence will be a particular object in a particular location with different aspect ratios and scale, and belong to a particular category. So that's what they are going to use the same bipartite matching laws like assignment problem using Hungarian algorithm, and also minimizing the regression error, and also the using the conferential proof. They try to indirectly predicting the classifications. So that's how we ready about. Later we will try to see how this encoder decoder mechanism works, how they transform this image problem into a sequential problem, sequence to sequence prediction problem, like a similar operation in the neural machine translation, which is being used in the standard GPT models. Thank you.